Hey everyone, welcome back to the channel. This is Florian, a passionate AI researcher, who craft insightful videos. In today's video, we're diving into some fresh insights on chunking strategies. 1. Is semantic chunking really worth the computational cost? 2. What exactly is late chunking, and how does it help preserve context in RAG? Let's break it down. Let's kick things off with the first big question: is semantic chunking worth the computational cost? This is something we've touched on before, but recent studies are shedding new light on the subject. So, what exactly is semantic chunking? Essentially, it's a method of splitting text into chunks that preserve the semantic meaning, rather than just dividing text into fixed-size pieces. But the big question is, does it justify the extra computational cost? 3 chunking strategies were tested, each with its strengths and weaknesses. Let's look at them quickly. First, we have the fixed-size chunker. This one simply divides the text into fixed-size chunks. It's simple and computationally efficient. Second is the breakpoint-based semantic chunker. This method inserts breakpoints where semantic distance between consecutive sentences exceeds a threshold, capturing topic changes but prone to local greediness. And third, we have the clustering-based semantic chunker, which groups semantically similar sentences together, even if they are not next to each other in the text. This could result in some non-consecutive chunks, but it helps ensure the overall coherence of the text. Now, the results of the experiments were pretty interesting. While semantic chunking did show occasional improvements, especially in datasets with diverse topics, it wasn't always better than simpler methods. In fact, on real-world data, the fixed-size chunking method often performed better. And, when it comes to practical RAG applications, the computational efficiency of fixed-size chunking makes it a more attractive choice. In addition, the impact of chunking often overshadowed by factors like embedding quality. In my view, the experimental results of this study are somewhat unexpected. Results show semantic chunking's effectiveness varies by tasks. Its high computational cost makes fixed-size chunking more practical for limited resources. From my perspective, future improvements should focus on dynamic adjusting chunk granularity to better match the context and distribution of topics. Better datasets are needed, as synthetic data lacks real-world complexity. Future work should test with longer documents across diverse domains, including specialized fields like medical and legal texts, to better evaluate semantic chunking's benefits. Alright, now let's talk about late chunking, a method designed to preserve context more effectively in tasks like RAG. Traditional chunking strategies split the text into chunks before embedding it, which can cause important context to get lost. For example, in a text about Berlin, pronouns like its and the city lose their connection to Berlin when chunked separately, leading to poor embeddings. This is where late chunking comes in. Rather than splitting the document before embedding, late chunking waits until after the full document has been processed, preserving context across chunks. The process of late chunking involves 5 main steps. 1. Tokenization. The entire document is tokenized into individual tokens, and their corresponding character lengths are recorded. 2. Embedding generation. The embedding model processes the full document and generates token-level embeddings for each token. 3. Chunk positioning. Iterates through the token embeddings, calculating the cumulative character length to determine where each chunk starts and ends. 4. Mean pooling. The token embeddings for each chunk are pooled using mean pooling to generate a single embedding for each chunk. 5. The final output is a set of chunk embeddings, each capturing both the chunk-specific information and the broader context of the full document. In general, late chunking is a relatively simple trick but shows strong performance. It impressed me that preserving context in RAG is very critical. In my view, late chunking requires a long context model as a prerequisite, which comes at a considerable cost. Further improvements may be necessary to handle large-scale applications more effectively. In the future, I envision enhancements like dynamic chunking strategies that adapt to the semantic density of the text. That wraps up today's content. I hope these technologies provide new ideas for your projects and research. If you enjoyed this video, Don't forget to like, subscribe, and hit the bell icon for more AI insights. Thanks for watching, and see you in the next episode.